Okay, so today as we continue on in our lesson that deals with slope-intercept form, as I stated a little bit ago, we're going to use slope-intercept form to help us graph. What are the two ways we've used already in our linear functions unit that we're in right now? What are the two methods we've used so far for graphing? One method, what's another? X and Y intercept method, when you can find the X and the Y intercept, you can graph a line because you only need really 2 points to be able to graph a line. What would be the only types of, we talked about this some on Friday, what would be the only types of lines that you cannot graph using the slope, not the slope, the X and the Y intercepts? Because there's no way you would get 2 points. And if you don't have 2 points, at least, you cannot graph a line. What type of linear equations would not provide 2 points for you when you're trying to find the X and the Y intercepts? Actually, a horizontal line, we only need the 1 point. We just need to know where it's going to cross the y-axis at, and then we can just draw a horizontal line going through it. So in reality, we kind of almost can, especially if we already have a coordinate plane set up for us that has the nice straight grid lines for us to draw them across. How about direct variation? Where does direct variation go through?
The origin.
The origin. So what's the X and the Y intercept? 0, 0 for both of them, right? The origin is the X and the Y intercept. Well, if we only have that 1 point, how are we going to be able to graph that line? So direct variation is the only type of linear equation that we cannot use the X and Y intercept method for, but any other ones we should be able to. What's the other method that we've used so far? Not even just in this unit, but before this unit. You should be able to graph any equation using this method. This is scary. How in the world are we going to have function after break when you have a semester final to take? When you've had a week and a half or almost 2 weeks off of school. Generate ordered pairs. Create a table. Pick X values, put them into the equation, get a Y value for it, have an input, get an output, generate ordered pairs. Okay, and that will work for any type of equation you want to graph. It doesn't matter what it is, it doesn't even have to be linear. Okay, so when we have a linear equation solved for Y, as they were in Friday's notes, it is considered to be in slope-intercept form. So reminder, our slope-intercept form is Y equals mx plus b. What's the m standing in for? Slope. The slope represents, the m represents slope, and what does the b represent? The y-intercept. So when we have the equation solved for y, we can pick out the slope, we can pick out the y-intercept from it, and the x and the y's are the ordered pairs that are the points on the line. So if you know the slope and y-intercept, you can easily graph it. So let's graph the line whose slope is 2 and whose y-intercept is -3. So it says start by plotting the y-intercept at 0, -3. So let's go put our y-intercept on the graph. 0, -3. Says the y-intercept is -3, or in other words, the b value is -3. And let's go and let's use that point to help us create more points. Now, hear me on this. I'll say it more than once, but I'm going to say it for the first time now. When we're using this method, as long as the coordinate plane that we have provided for us supports it, we're going to have a minimum of 3 points. So the y-intercept can be one of those points, and then we need 2 others at a minimum. So if we're going to use the slope of 2, that really means a rise of what? 2 and a run of 1. So we can graph it using the 2 over 1. But why can we also use -2 over -1? Because that is also positive 2, right? It divides out to positive 2 also. So let's use both of them. Let's go up 2 from our y-intercept and 1 to the right because we got to go in the positive direction both times. Let's go back to the y-intercept and let's use the other one. Down 2 and 1 to the left in the negative direction both times. There's our minimum of 3 points. I like to go crazy and make a few more so that I can make sure I get a good line when they're especially this close to each other. So take your ruler now, as using it as a straight edge, draw a line going all the way through the graph, not just through the few points that you plotted. And stick arrows at both ends. And then check to see if the behavior of the line matches what it should. What type of slope did we have? Positive slope. Our m is 2. Our m is a positive number, so since our slope is positive, we should expect the line to do what? Rise from left to right, and is ours rising? Okay, well at least the behavior matches the type of slope. Okay, what would the equation of this line be?
Y equals 2x plus negative 3.
Okay, y equals 2x plus negative 3, which cleans up to what? Minus 3, right? Plus a negative 3 cleans up to minus 3, okay? Well, if we graphed it right in the first place, and if we wrote the equation correctly that goes with, the two together should work when we check some ordered pairs from that line. So let's check some of the ordered pairs that are on that line. Let's check 3 of them, it says. Okay, so check 3 points from the line in the equation. So our equation is this. So y equals negative 2x minus, no, it's not a negative 2x, it's a positive 2x. Positive 2x minus 3. Y equals positive 2x minus 3. Y equals positive 2x minus 3. We're going to use the equation 3 times with 3 different points and make sure that it checks out. So if our line and our equation match, they should check. So give me an ordered pair that's on that line.
3, 0, negative 3.
0, negative 3 is, the y-intercept is. So we will substitute in for our y value, negative 3, for our x value, 0. Negative 3 equals 2 times 0 is 0. So we'll have 0 take away 3. And what is 0 take away 3? Negative 3. Okay, that one checks out. Okay. Give me another ordered pair that's on that line. AJ?
0, negative, or no, sorry. 2, 1.
2, 1. Okay. So when we substitute it in, what's going in for y?
1.
1. What's going in for x? 2. So you should be doing this with me. 1 equals, 2 times 2 is?
4.
4. And what's 4 take away 3, class? 1. Okay, that point checks out. Give me another point, another ordered pair, Brayden, from this line.
3, 3, 3.
3, 3. Okay. So 3 for the y value, 3 for the x value, and take away 3. So 3 equals 6, take away 3. 6 take away 3, class is?
3.
3. They all 3 check out. How many others should check out? All of them. Well, how many are there?
Infinity.
Infinite. There's an infinite number of solutions for this equation, for this line. There's an infinite number of points. So basically what this checks is, does our equation at least match our line? If we graphed it wrong, then chances are we are, but yeah, we have the same, the right equation for our line. We might be misled that way, but if we're just checking to see if we have the right equation for the line, this would help us make sure that we did. Okay, any questions? Okay, let's go on to the back side. Okay, graph a line for the equation. Y equals -1/4 x minus 4. First question I have for you is that equation in slope-intercept form?
Yes.
What's your instant clue? How can you instantly look at that and say, you know what, this is graphing friendly, it's in slope-intercept form?
It's like the Y goes down.
Yeah, it's got the y all by itself. If the y is all by itself, you're like, cool, this is in slope-intercept form. All I need is that y by itself, and now I can figure out the y-intercept and the slope. I typically pick out the y-intercept first, because that's the first thing you do on the graph. That's just my way of doing it, and then I pick out the slope. So what is the y-intercept in this one, or our b value? -4. Why isn't it +4?
It's -4.
Yes, it says -4, and our form says plus b, right? So we have to say, this got cleaned up from being plus a -4 to being a -4. So our y-intercept is -4. Okay, what's our slope?
-1/4.
-1/4. Okay, tune in. If it's a negative slope, that means what?
It's gonna fall from left.
It's gonna fall from left to right. So does that mean both the rise and the run will be negative? Only one of them has to be. So let's come up with both ways that we could use this slope to graph points. If we make the run negative,
Yeah.
then the rise would be, or the rise, excuse me, if we make the rise negative, then the run would be positive. Or what's another choice?
Make the run negative.
Make the rise positive and instead the run negative. So give the negative, you know how we pull it out when we do the counting method or when we use the slope formula? Same thing, we can put it back in where we're going to use it for graphing. So we're going to graph this by starting at our y-intercept. And I want you to use that slope in both names. I want you to go down 1 from it and right 4. And I want you to go up 1 and left 4. So that we get used to not always going just in the same direction all the time. Sometimes we have to because that's how our coordinate plane works best. But in this case, we don't. And then draw our line all the way through the graph. And we said it should be falling from left to right, so we're happy with that. Why isn't it very steep?
Because your rise is only -1 or positive.
Because you're running more than you're
Right.
rising. The slope is, its absolute value is what? What is the absolute value of -1/4? So it's 1/4 that you'd be unit away from 0. It's pretty darn close to 0, isn't it? The closer the slope is, the absolute value of the slope is to 0, the what? The less steep it will be. Okay, so all of those are things that we should use to help us make sure that we are doing a good job with it, okay? Okay, now it says graph the line for the equation 3x minus 2y equals -15. Is this in slope-intercept form?
No.
What form is it in? Standard form. Standard form is the most friendly for what? Finding intercepts. But what does it say they want us to do?
Graph line using the y-intercept.
Using the y-intercept and the slope. So from standard form, can we just pick it out like and say, oh, let's see, that 3 is the slope and that -2 is the y-intercept? What do we have to do? What's our first move in this one?
Subtract 3x.
Subtract 3x from both sides. We got to get it put into slope-intercept form. What do we have on the left side now?
-2.
-2y. Okay, and yes, that can be rewritten as negative 2y equals negative 3x, because we can change that to add the opposite, and then these two can trade places. And it's a good idea to remember because why? What happens when we have subtraction and dividing by negative? Yeah, change to a positive, and sometimes we mess that up because we think the subtraction is unaffected. So what are we going to do to every piece now?
Divide by negative 2.
Divide by negative 2. Our equation now reads,
Y equals.
1.5x.
do we want to change it to 1.5?
No, 3/2.
Yeah, remember, we're going to leave them as improper fractions, so we still have our rise over our run in integer values. We want integer value rises and runs. It's easier to graph. So 3/2 x plus this we want, because we want to know where on the graph, so we can change the y-intercept to its decimal name or its mixed number name. But we do not want to do that with the slope, because then we don't have nice integer rise and run. So what's our b and what's our m?
B is 7 1/2, and B 3/2.
Okay, and when it's 3/2, what's our other option?
Negative 3/2.
Negative 3/2. They both will accomplish the same thing for us, won't they? Okay, so go ahead and get that graph, and be careful with the fact that now you are not on intersection of integer values. Can we use the positive 3/2? No, we go off the grid and then we have to create more grid lines. So what are we going to do instead this time? Use this one how many times?
2.
2. We're going to do it twice. So we'll go down 3 and over 2, down 3 again, and over 2. We can keep going in the same direction. And then we will graph our line. How do you feel about this? Do you feel like we have a good line?
Yes.
According to us, the slope should have been
Or 3/2.
positive, and that means it should
B is
rise.
rise from left to right.
Okay, now tell me something. If we did find the x-intercept, remember we could ignore the minus 2y, couldn't we? What's the x-intercept? 3x equals negative 15. What's the x-intercept for this one? Negative 5. That kind of looks like where we're at, doesn't it?
Yep.
If we want to get the y-intercept, well, we can ignore the x. What's negative 2y equals negative 15? What would that solve to? Negative 15 divided by negative 2 would be 7.5. So we have our y-intercept. So that's another way to kind of check that we have what is given to us in standard form to start with. It's pretty painless to find the x and y-intercepts to help make sure that we have a good graph, okay? Anybody have questions? Okay, then I'm going to assume you know how to graph these, huh? Okay, get out some loose leaf to do the other parts on, and then I will give you the graphs handout for graphing.